Hello all, welcome back to System Design Interview Series. Today's topic is caching, which is a follow-up session from the initial caching session part 1. And in this particular session, we talk about the different read-write patterns and the associated caching patterns and specific solutions which can be used to solve specific scenarios. Just brushing upon the topic of cache pattern, what does it mean? So caching pattern suggests to store frequently accessed data under the cache from data store. So frequently accessed data is stored in a in-memory kind of a solution so that reads are faster, updates are faster, and to meet the performance requirements of an application. So core considerations for deciding on the cache solution to use in different scenarios. Important aspects, 4 of them. Read-write pattern, consistency requirement, eviction requirements, and nature of data as per the requirements. Nature of data means static data, real-time data, dynamic data, or even the nature of data in the sense whether it's a doc, whether it's an image, whether it's a streaming data. So let's deep dive into each of the read-write patterns and look for what kind of a solution can be utilized in that particular scenario. Read-heavy pattern. Majority of operations under these patterns are read, and cache helps in optimizing the performance and reducing the load on the data store. Considerations on caching strategy. Cache aside, read through, refresh ahead pattern can be used, and a specific caching solutions should provide these caching strategies. Cache consistency. Staleness of data can be of concern because this is a read heavy pattern, and when reads are happening, it should in more probable cases it should always give the most up-to-date data. But still, in this particular read heavy pattern, generally eventual consistencies are often acceptable. Eviction policies, least recently used or LRU in short, and time to live policies are used. LRU ensures that hot data remains in the cache. By hot, what we mean is frequently accessed data, and TTL ensures that every record has a expiry and is reloaded periodically after its expiry. Example use case, content management system. User views the articles more often than edit the article. So let's jump into the caching solutions for this pattern. Redis, because of its in-memory architecture, supports multiple data structures to optimize data structures to ensure fast reads and fast writes. Replication is supported, and it's high availability in the sense when we talk about Redis clusters, they are highly available. They ensure that the data is replicated across. And TTL expiry, time to live expiry, ensures that data, up-to-date data is always there in the cache. Memcached is another one, which is a simple key store value store. Distributed caching it supports, and it's a lightweight process, so it has minimal overhead. Apache Ignite comes from Apache's house of open source solutions. Features distributed in-memory support, data affinity, persistence option. So it allows in terms of replicated data over sharded or the sharded data, it ensures that data affinity, it provides the feature, and data awareness is available with the Apache Ignite using the data affinity, which helps in faster retrieval and faster updates. Varnish, it's a lightweight CDN process kind of, where it helps in content caching, HTTP accelerator, and high performance on those web contents. A cache, Local and distributed caching, it provides the support feature, and it has a very simple API based integration, and it provides a flexible eviction policies. So in this read heavy case, when we are talking about high throughput, high traffic web apps, then Redis, memcached, and Varnish are the solutions to look for. For distributed caching, Redis, memcached, Apache Ignite, and Acache. For cloud-based systems, Elastic Cache, Google Cloud, Memory Store as a managed service. Again, the solutions which are listed out are limited in nature. There may be many more. These are few of the ones which I could uh, do some analysis and recommend for this read heavy pattern. Write heavy pattern. Majority of operations are write, and cache needs to handle frequent updates and maintain consistency. Considerations from caching strategy perspective: write through, write behind patterns used. Write through and write behind ensure that cache is up to date and it's always the first place which is getting updated. And then the data store is either asynchronously getting updated or synchronously getting updated. Cache consistency. Strong consistency may be required to ensure reads acquire the latest updated write data. Eviction policy, TTL or time to live policies are used to keep most frequent data under cache. One of the examples for this write heavy pattern can be OLTP or online transaction processing systems in which frequent updates to customer info is necessitated in lieu of the transactions being carried out and all those stuff, right? So what are the different caching solutions for this pattern? Redis supports fast writes, persistence options of uh, append only file or Redis, um, optimized data structures and replication and sorting. Apache Cassandra, write optimization is there, log structured message trees are you merge trees, sorry, log structured merge trees, LSM trees are used for managing the writes. High availability and linear scalability, adding more nodes to Cassandra is easily feasible, and it takes care of managing or distributing the data across. Amazon DynamoDB, it write scalability, it supports durability and replication. So it's durable in nature. It can persist the particular data, and it also supports write throughput optimization. Aerospike, write optimized for flash or slash SSD. So a hybrid approach of storing the data between flash and SSD and ensuring the hybrid memory structure architecture, ensuring fast reads and fast writes, automatic data replication feature, and highly available. HBase. So write optimized storage, again it uses LSM, that's log structured merge trees structure. Batch writes, it supports a strong consistency, and multiple consistency models also are supported under HBase depending on the different scenarios. In this particular case, strong consistency. Apache Ignite, distributed write handling it supports. Write through and write behind are the two features which it supports, again needed for this particular pattern. Durability options, in the sense it can be, the data can be persisted, and data partitioning, so sorting and partitioning of the data is inherently seamlessly taken care by Apache Ignite. Couchbase, memory first architecture, in the sense data is first updated in the memory in cache and then it's updated back to the data store. Sync and async writes, high availability, high scalability, and write durability. Whenever a write happens, you can consider under couchbase it will be durable. Hazelcast, a distributed in-memory grid, supports write behind, asynchronous write backs to the data store after the data is updated in memory, high availability and persistence it supports. Google Cloud Bigtable, optimized large-scale writes, column-oriented NoSQL, auto-scaling is supported. voltdb, in-memory and high-speed writes, ACID compliance. Important aspect here is cache providing ACID compliance and distributed writes. Read-write balance pattern. In this pattern, there is a balanced mix of read and write operations. Cache needs to handle efficiently both the operations, often requiring more sophisticated strategies to maintain the performance and consistency. So considerations from caching strategy perspective, cache aside with a combination with the read through and write through strategies to maintain the performance and consistency. In the sense, cache side, while it loads the data, it does a lazy loading of the data with a combination of read through and write through strategies. The cache ensures that the data is read and written through the cache and it maintains most up-to-date data. Cache consistency. A tunable consistency model might be necessary to balance performance with the data accuracy, because when we are talking about write through and read through, there are some certain corner challenges which we have spoken about in our last session. So it's important to ensure the consistency models have the necessary balance. Eviction policy, combination of LRU and TTL to ensure that the most frequently used data remains in the cache, as well as all the records have a periodic expiry so that the most up-to-date data is loaded. Example use case can be social media platforms. Frequent updates from a particular user as well as reads from the same user may be initiated. So a combination of read-write balance pattern. Caching solutions for this pattern can be redis because of its in-memory speed, persistence option, pub/sub, and streams. So it supports redis also supports public subscriber model and handling of the streams, replication and clustering for any kind of scaling challenges. Amazon DynamoDB auto scaling, it supports flexible capacity, read-write consistency, it supports the global tables in the sense for global distribution of the cache. Aerospike, hybrid memory structure, strong consistency, automatic data replication, and low latency are some of the key features of Aerospike. Cache, in-process caching, write through and write behind are supported. Clustering support is there. Flexible configurations are there. Apache Ignite. It, the key features are in-memory grid, write through and write behind caching strategy support, data affinity in terms of different partitions of data done, and the amount of data which resides with each of these arts and all is managed by Ignite. Durability and persistence, it ensures that your data is durable as well as persistent. Couchbase, memory first architecture. Memory is first updated before touching upon the actual data store. Sync and async writes, flexible consistency, high scalability, and write durability. Hazelcast, distributed in-memory grid, write behind support, flexible eviction and persistence policies. Google Cloud Spanner, horizontally scalable, strong consistency, automatic sharding. When we are talking about cloud native solutions, Spanner can be a good candidate when uh, GCP is in Google Cloud Platform is in picture. Cassandra, high write and read scalability are supported. Tunable consistency, peer-to-peer architecture. These are the read and write balance patterns caching solutions. Again, these are not just limited to the ones which are represented here. There can be many more. Write once, read many, or warm pattern. Under this pattern, system writes a data once but accesses it many times. Some of the considerations from caching a strategy perspective: cache aside or read through suits this case, as data is not updated that often. Cache consistency: data is immutable in nature, so consistency is not much of a challenge here. Uh, eviction policy: eviction policy may not be needed as data is immutable. TTL or custom eviction should be implemented in case of deletion of record from the primary data store. Example use cases can be content delivery network serving static web assets, URL shortener service. Once a shortened URL has been generated, it may not be updated for its lifetime. Only action which might be possible is deletion of the record, in the sense the URL which has been mapped and its shortened code may get deleted. Cache solutions for this particular pattern: Amazon CloudFront in case of web content, CDN for static content with its global distribution and immutable nature of the content. Varnish Cache, as previously specified, a lightweight CDN with HTTP caching, cache invalidation, and edge and reverse proxy feature support. Redis with persistence. With persistence, Redis needs certain configurations to be carried out. Features supported on top of it is in-memory performance, persistence using AOF, append only file, uh, eviction policy TTL, which is supported, required for this pattern. Couchbase, fast reads with indexing, memory first architecture, durability for write once. Elasticsearch, search optimized reads, efficient indexing, clustered and distributed nature of overall Elasticsearch solution. So these are a few of the solutions which can be applied to this write once and read many or warm pattern. Write mostly with periodic reads. Under this pattern, system frequently writes data, but read access is infrequent and periodic or in batches. Some of the considerations based on caching strategy: write through or write behind strategies to ensure that data reflects the latest and most up-to-date data when read occurs. Cache consistency: strong consistency may be expected if the requirement looks for cache to provide up-to-date data. Eviction policy: TTL-based eviction might be useful to ensure no stale data is served. Example use case can be an IoT system. In an IoT system, IoT devices frequently write data into the server based on their sensors, but reads are periodic or scheduled ones in nature based on the requirements of when or at what point or what frequency the analysis on the sensor data or the IoT device's data needs to be carried out. Cache solutions for this particular pattern: tools like Cassandra, Aerospike, and DynamoDB excel in handling frequent writes with low latency access to recently written data. For time series data, influx DB, Bigtable are excellent choices. And systems like Apache Kafka or RocksDB are suited for event-driven or embedded write-heavy application. So when we are considering embedded systems or time series data or handling highly frequent writes and low latency requirements, these are the three different categories on the basis which some of these solutions can be picked up. Again, not just limited to this, but these are the few ones which I have listed out. Read burst pattern. Under this pattern, system experiences high read activity followed by no or low activity. When I say activity, read activity. Considerations: cache strategy. Cache side with cache warming or refresh ahead can help prepare for sudden spikes or bursts. Cache consistency. Eventual consistency may be expected if requirement doesn't look for cache to provide up-to-date data. Eventual consistency. Eviction policy LRU plus TTL to ensure most frequent data is always there in cache, and time to live expiry ensures that all the data records are refreshed periodically with the latest data. Example use case can be a news website with any breaking news. Read burst can happen, but such events of breaking news cannot be anticipated. Every breaking news will not drive the kind of traffic for a read burst. Cache solutions for this particular pattern. Tools like redis and memcached provide fast in-memory cache access, making them ideal for sudden spikes in read traffic. CDNs in Amazon CloudFront and Google Cloud CDNs or Akamai based CDN are great for caching static content and distributing it globally, minimizing the latency. Aerospike, Cassandra, Couchbase offer distributed architecture that is scale well, allowing them to handle large bursts of read traffic effectively. One important aspect to look at when we are talking about cloud CDNs like CloudFront and Google Cloud CDN is these are managed services. All security patches, all the admin jobs related to that particular platform and services is owned by those specific cloud providers. The advantage. Write burst pattern. Under this pattern, system experiences sudden high write activity, which cache needs to absorb efficiently without compromising consistency. Some of the considerations: caching strategy. Right behind caching can help for prepare for sudden spikes. Right behind, why? Because the data is first written into the memory of the cache, and then there's a background job or process which takes care of in synchronizing that particular data record into the data store. Cache consistency. Ensuring consistency during write bursts can be challenging, but uh, important is to ensure that through batch writes and consistency is expected at certain level, if not perfect consistency, actually eventual consistency may be required. Eviction policy LRU plus TTL becomes the norm even in this particular pattern to ensure that most frequently accessed data is there always in the records, as well as TTL ensuring that all the data set records are refreshed periodically. Cache solutions for this pattern: Apache Kafka and Amazon DynamoDB handle large-scale event streams and high burst capacity, are known to handle them efficiently. Redis with persistence and SkylarDB are optimized for low latency write operations. Tools like Cassandra, HBase, and Bigtable excel at handling distributed high volume write traffic, making them perfect for this scenario, which involves periodic or bursty writes. These are again some of the solutions for this write burst pattern, but not all. Sequential access pattern. Under this pattern, data is accessed in sequential manner and in predictable cadence. Consideration, caching strategy. Cache warming or priming can preload the data and optimize the performance. Cache consistency. Minimal consistency concerns as data access follows a predictable path, so consistency is not a major challenge. Eviction policy, FIFO, first in, first out, or a custom sequential eviction policy also can be applied here. Example use cases can be video streaming platforms. Services here handle video segments sequentially as accessed by the user, which follows a very sequential or strict pattern. Cache solutions for this particular pattern, tools like InfluxDB, Google Bigtable, and Cassandra are highly efficient for handling sequential reads and writes at large scale. Redis, with sorted sets, and LevelDB provide fast, lightweight solutions for a smaller application needing sequential access. TimeScaleDB, HBase excel in managing time series or log data that require efficient sequential reads over large data sets. So if you are dealing with building a system design for a trading platform where time series data of the stocks are coming in, either TimeScaleDB or HBase can be utilized. When we are dealing with the client side of the same solution, we should talk about Redis and LevelDB. And when we are dealing with the entire ecosystem of it, with the service side of it, InfluxDB, Google Bigtable, and Cassandra can be considered. Temporal access pattern. Under this pattern, the access data is time dependent, with certain data being more relevant in specific periods. In the sense, the data or the cache data is relevant based on the time period. Some of the considerations: caching strategy, time-based preloading and refresh ahead pattern can help manage data. So what is meant here is like, if it's a known pattern that a specific caching requirement per se says last 7 days data. So storing that last 7 days data into memory can optimize the performance. Cache consistency. Time-sensitive data may require a strong consistency because the data for that particular specific time period needs to be consistent all across. Variations can lead to challenges. Eviction policy, TTL-based policy should work because data has to be always refreshed and most up-to-date data should be there. Example use case can be event-driven system platform. So sports score tracking. Here data is relevant only during the game. Post the game, the data may not be required. It can go back to a cold storage. Cache solutions for this particular pattern: InfluxDB, TimeScaleDB, and Bigtable again come into picture. Redis with TTL and Cassandra offer flexible and efficient caching with built-in support for temporal data. Elasticsearch and Kafka are also time-based log aggregation and event streaming platforms and help in this particular temporal access. Expensive operation pattern. Under this pattern, cache is used to store expensive computes and complex calculation results. Considerations: caching strategy, cache aside or read through, combined with aggressive caching of computed results. So cache aside ensures the lazy loading of the data, and read through ensures that most up-to-date computed result is stored in the data cache. Cache consistency. Cache consistency is not such a critical one in this particular pattern. The reason is the calculated values do not more often change. So consistency may not be a major challenge. Eviction policy, long TTLs to avoid recalculations, as the day cache stores expensive operations outcomes or computed results. TTLs are set to substantial long values so that the data is not evicted very frequently and need not be recalculated. Example use cases, data analytics platforms. These platforms generally involve high compute and the outcomes are stored under cache for readily making it available for any subsequent request or query. Cache solutions for this pattern, Redis and memcached are top choices. Caffeine and Guava provide the lightweight in-memory caching option, primarily targeted towards Java applications. Cache and Hazelcast offer advanced features for distributed caching in enterprise application, keeping the data or the cache in memory. And tools like Apache Ignite are one of the examples for a large-scale distributed system requiring high-performance caching for expensive computations. With this, I'd like to summarize today's session. Today we covered 10 different read and write patterns, the associated considerations, what are the different scenarios in which each of these patterns fall into, the nature of data, and based on the nature of data, what can be the different solutions or caching solutions which should be considered. Important aspect covered are the 4 different criteria of design decision of which particular caching solution should be picked up. With that, I'd like to end today's session. Happy for you all to be staying back with me till the end of this particular session. This was a longer one, but important because caching is one of the core subjects or topics on system design interviews. With that, hope to see you all soon on my subsequent session. Till then, happy learning and bye-bye.